So today we're going to start with set data type, but before getting into the Python part, let's begin with what are set. So this is a mathematical topic. If you have taken like maths in your +1, or then you would know that what sets are. But if you have not, I'll give you a brief overview about what set is and all that is required to understand the set data type. Okay, so what are sets? Set is basically a collection of similar kind of an object. Okay, so like if you see on the right hand side, I have made a circle, which has 2 4 6 8 10, right? So what are these numbers? What's the similarity between them? So they are even positive number from 0 to 10, right? In between 0 to 10, right? So we have grouped similar kind of data together. That is set. Very easy. This is the mathematical or numerical data, but we can also have categorical data like fruits. If I have like fruits over here, like apple, mango, banana, all that, if I segregate them by color, that is going to be another set, right? So this is what sets are. This is the example I've written. Okay, so there are two ways to write sets. Basically, one is using the curly braces and writing all the elements. So I've written all the elements. Or the other way is when we have a lot of elements, what we do is we write the relation. So the relation, the common similarity between all these elements is that they are positive even number which are less than 11. So that is the similarity. So if we give that information, it is very easy to figure out that only these 5 numbers, these 5 elements are part of the set A. So that's two different way to write set. Okay, so this is set. What is set? A well-defined collection of objects, okay, which can be numerical, categorical. They basically have something some similarity attached to it. Okay, that is set. We have different types of sets, so let's go through them. They are very easy, so it won't take very long. Let's just quickly go through it. So let's start with different types of set. The first set is empty set. Empty set means it has no elements. Okay, so to understand it better, we all know natural numbers are like 1 2 3 4. We don't have decimal points in them, right? So I have given the condition that x is a natural number which is in between 7 to 8, and we know there is no number in between 7 to 8 that can be written without using the decimal. So we have 0 elements falling in this category, right? So it has no elements. See, this is the set and it has 0 elements. Cardinality means the number of elements. So in this, the cardinality is 0 because we don't know the number. There's no element in it. That's why it's an empty set. That's why its cardinality is 0. It is denoted by this symbol. It's a finite set. What is finite set? We'll see. The next set that we're going to do is finite set. So this is empty set. Very easy, right? Next is finite set. Sorry, with the mispronunciation. Finite set is a set which has a very defined number of elements. Like we can count those number of elements, right? It's not unlimited or uncountable or infinite, right? So that's finite set of elements. So we have taken the same example and see, we can count. If I did not specify this condition, then the even numbers are uncountable, right? We can go up to infinite, but because I've specified that it should be less than 10, see, it has become finite because we have set a limit, right? Infinite is, see, all natural numbers, so we cannot count up to that, so it's infinite. So wherever the number of elements are uncountable, it's infinite set. We cannot understand its cardinality, right? We cannot define its cardinality. That's infinite set. Next is subset. So what is subset? Subset means it's a part of a bigger picture, right? See, this is a subset. A is a bigger set. A has all the natural numbers 1 2 3 4 5 6, and it goes up to infinite, right? But the B set, it has given us condition that it should be an even number and it should be less than 10, right? So that leaves us with only 5 elements. So all these 5 elements are natural numbers. So all these elements are part of this bigger picture, right? So I think you got the picture, right? Like if a set is part of another set, right? Because all these elements are part of this set, right? We have 1 2 3 4 5 6, all this in A set, but 2 4 6 8 10, those are the elements that we have in set number B. So set number B has all the elements that are part of A, set A, right? That is subset. Proper subset is, see, the major difference is here all the elements fall in this category only, right? To have proper subset, you have to have at least one element that is not part of the bigger set. Here A is the bigger set, B is the smaller set, or the subset. This is superset. The bigger one is superset. The smaller one is subset. So the superset, the difference between subset and proper subset is this subset should have at least one element that is not present in A. To understand this better, see, we have taken the set A as all the natural numbers. Set B, we have taken even number from -5 to 10. So natural number starts from 1. We don't have negative in natural number, right? So the -4, -2 and 0, they are not a part of A, right? We don't have these elements in A. So this is a proper subset because we have some elements that are part of A, but some that are not. So if we have only one element also that is not part of the superset, then it is a proper subset. Understood? Next is singleton or unit set. Oh, I wrote it wrong. I'll correct it. It means that it can only have one element. See, here the only number which is neither positive nor negative is 0, right? So it is a singleton set or unit set. Very easy. Equal set means two set having same elements, like not same number, exactly same elements. So I have done something, I have just added it, and so there can be other options also, like suppose I have 1 2 3 4 in A and 1 2 3 4 in B, so they are also equal set. If they have same elements, exactly same elements, then it is equal set. What is equivalent set? If their cardinality is same, that means number of elements in both of them are same, then it is, what do we call that? Equivalent set. Every equal set is equivalent set, but every equivalent set is not equal set. Okay? Cardinality, we know, number of elements is cardinality. Here they have same cardinality, but the numbers don't match, right? So they are not subset of each other. In fact, they don't even have any common element, right? But they are equivalent set because they have same number of elements in them. And they are disjoint set because they do not have any same elements. If two set have no same element present in each other, then they are disjoint set. Easy? Let's move on to operations. They are also very, very easy. Okay, like addition, subtraction that we do on basic integers and numbers, we can do operations on set also. So we're going to see three basic or very important operations on set. So let's go through them. First is union. Union basically means addition. Okay, so this is set A, this is set B. So if we do A union B, we have all the elements of both. So if I write it in like curly braces, so how it is going to look is it will show numbers like 1 2 3 4 5 6 7 8 9 10. So A union B is equal to, in curly braces, 1 2 3 4 5 6 7 8 9. That is union. We include all the elements from both the set. If they have anything common, it is written only once, not twice, only once. Okay, that is union. Next is intersection. So intersection means the region that is common in both the set. Okay, the region, the set, the common values in both the set shows intersection. So we saw this example, right? So in this, the negative is not present here and these numbers are not present here. So the common part is 2 4 6 8 10. So that is A intersection B. So what are we going to write in A intersection B? 2 4 6 8 10, because These are the common elements in both the set A and set B, right? Next is difference. So what do we do in difference? Difference is basically you remove the intersection part. Rest everything is included in difference. Okay, so this is the intersection part. So what will this set include? It will include 1 2 3 4. No, it won't include 2 4. It will include 1 3 5 7 9 11 12 13 14, all these up till infinite, because it is an infinite set. And in the negative portion it will have -4 -3 -2 -1 0. So that is going to be difference of set. That is, these are the elements that are going to be included in A minus B. Got it? If you have any doubt in the sets, you just let me know. We're not doing any practical questions because it won't be of any use, but if you want me to do any practical questions, just let me know. So let's begin with a set in Python. So we know what set are, right? So they are exactly same thing, but we're going to do the same thing in Python. There are some little difference, some little technicalities of Python that we're going to add in the same concept we just did. So let's just start. So see, the first line says that it is a data type that helps us deal with mathematical sets. The one that we did just now, okay? It is derived data type because we use fundamental data type as its elements. Okay, so it is derived data type. And see, this is something interesting. Set is mutable, but the elements in it has to be immutable. Okay, so the elements that you enter in the set are immutable. They cannot be changed, right? We cannot add, we cannot remove the elements, but we can make changes in the set. Interesting, right? We're going to see that with hands-on practice. Next is, it is unordered. That means in whatever order you enter data in set, but the output that you get is uncertain. You might get the same output as you entered, or in a completely different way every time you run the program, right? That's how it's unordered. Exactly, that is why the iteration is same, but the order of output is different. It is going to be different every time. And we cannot do slicing or indexing in this. Slicing means, slicing we cannot do because there is no order. To do slicing, we need order because we use, that specific positions. So that's why we cannot do slicing. And indexing is also the same reason, because we haven't assigned a specific position to that data or elements, right, in the set, because they are unordered. Like set, all the values are unique. We cannot have any same value. If we enter in same value, it is going to remove. Okay, so set initialization. Let's do set initialization with Jupyter only, right? So let's create a set. What to enter in it? So in this, I cannot pass a list because list is mutable, right? We'll see that when we use set function. Right now I'm just showing you a basic. Oh, sorry. I have to put it in a string. Because otherwise how it is going to know what data type it is, right? It has given me a string. I entered actually just one value. It should be separated by commas, right? I quickly do that. See, now we have 5 elements. Okay. Let's just see how we can create a set using the set function. So before I go ahead with that, let me create a list. And I'm going to use the same elements, okay? It's a different set, but it is going to have same elements. So this is a list, and I'm also going to create a tuple because tuple is immutable, right? List is mutable and tuple is immutable, and we know set is going to take only mutable items. It did not raise an error. That's strange. Let's just see. No, it is accepting a list also. That is strange. But the documentation says it can only take immutable. This is mutable. I don't know why it is doing that way. Let's just take it with tuple also. So it is accepting both list and tuple. Maybe if I pass this, it might raise an error. It should raise an error actually. It is not. I'm surprised. It is not. I'll check the facts and let you know. But you understood, right? This is how it is initialized. Now that we have done set, before moving forward, let's just settle with why this list is, working. Why is it not raising an error even after being mutable? Okay, so I'll just check. Give me a sec. So the reason why this code worked even after saying that it only accepts immutable value is because Python actually, implicitly converts the list into immutable list. That the set function, it does internally. So what it does is it internally converts the list into immutable list. Usually lists are mutable. So it has taken a mutable list, it has converted into immutable list, and then those elements are sent into the set. That's why it has worked. Okay, I actually googled it, so that's what it said. So that is it. Now that we know what sets are, let's quickly understand a very, very short and sweet concept, a short and sweet data type. That is a frozen set. So what is frozen set? Oh, I actually have something written over here, so let's just quickly see. Frozen sets are similar to set, except they are immutable. Okay, how do we know that they are immutable? Right? The set were mutable and these are immutable. We're going to check how it is immutable. Okay, to initialize frozen set, we use frozen set function. So that's what I've done. I've taken the same code, right? I've just changed is frozen set. Okay, and I've run this code. Okay, if you see, I haven't changed the name of the set, frozen set, right? It's set2 and it's set2. So it changed the data in it, but it is immutable. Why did it change? You must be wondering, right? I'll show you why. I'll show you how it is immutable even after it accepted the change. Okay, so we're going to do is, before changing, see, this is where I assigned the values. So I have printed the values. Now I'm going to print the ID of the set with the list. Then the same set with tuple, I'm going to print the ID. Okay, see, we have different ID. This has 384 in the end, this has 848 in the end. That means it has given this set with the tuple a new memory address. So we definitely have it stored somewhere around this memory, but it might have the same name, but the ID assigned to it is new. That means we are not making changes in the same memory ID. It has been assigned a new memory ID. Okay, and it is immutable as we cannot add anything or remove anything. Okay, that is why it is immutable. That's the reason why most of the time we use frozen set to assign keys to the dictionary, because the keys to the dictionaries are immutable and they are unique. So that's the two conditions that are required for the keys in dictionary, and that is the two conditions that frozen set satisfies. So now that we have understood frozen sets and sets, let's move on to the next topics in the next videos. And thank you for watching. If you have any doubts, do let me know. Bye.